Hello, my dear students. Welcome back to CSIR NET June 2021 Crash Course Series. Today we can study enzyme kinetics. What is enzyme kinetics? It is the study of rate of enzyme catalyzed reactions. Just look this example. Here E represents enzyme, S represents substrate. This is ES. ES complex, enzyme substrate complex. This is enzyme, P product. Enzyme combines with this substrate to form enzyme substrate complex. And this enzyme substrate complex convert into enzyme and product. And here enzyme combines with substrate to form enzyme substrate complex with a rate constant K1. What is rate constant? The initial rate of a chemical reaction can be expressed as a constant. It is known as rate constant. And it is determined by the concentration of reactant and by a rate constant K. For example, here the substrate is converted into P. Which is the reactant here? S. So the rate is equal to, rate means velocity, initial velocity. V is equal to rate constant. Rate constant is K into the substrate concentration. That is S. So rate is equal to Ks. Here we can check. Enzyme plus substrate combined to form enzyme substrate complex with a rate constant K1, first reaction K1. This enzyme substrate complex can dissociate back into enzyme plus substrate, or it can convert into enzyme plus product. If it is converted back into enzyme plus substrate, the rate constant here K minus 1. And if this enzyme substrate complex converts into enzyme plus product, here rate constant is K2. And this is if enzyme plus product convert back into enzyme substrate complex, rate constant K minus 2. And this K minus 2 is negligible because during the initial stage of a reaction, this K2 is negligible. So we can take only these three constants, K1, K minus 1 and K2. Here we studied the rate constant. The rate is equal to rate constant into substrate. So we can check here. The rate of formation of ES, that is enzyme substrate complex, is equal to rate constant. Which is the rate constant of ES formation? Which is the substrate here? These are the this is substrate, yes. So here this rate of formation of ES depend on K1 into E and S. And rate of breakdown of ES is equal to two constant here. This rate of breakdown of ES depend on two constant. Which are they? K minus 1 and K2. We studied that this enzyme substrate complex can dissociate back into enzyme and substrate, or it can convert into enzyme plus product. So here the breakdown of ES has two constant, K2 and K minus 1. So the breakdown of ES is equal to K2 into ES plus K minus 1 into ES. So that is equal to K minus 1 plus K2 into ES. These three rate constant we can express by a single constant known as Michaelis-Menten constant. So Michaelis-Menten constant is represented by Km. Km is equal to K minus 1 plus K2 divided by K1. This is Michaelis-Menten constant. This is the graph for enzymes that obeys Michaelis-Menten kinetics. Here, x-axis represents substrate concentration and y-axis velocity. Here at relatively low level of substrate concentration, here this one is substrate concentration and here velocity. So at initial stage, at relatively low concentration of substrate, V0 increases almost linearly with the increase in substrate concentration. This one you can see here. At higher substrate concentration, what happens? This region, V0 increases by smaller and smaller amount in response to increase in substrate concentration. So first V0 increases almost linearly with the increase of substrate concentration. At low concentration of substrate, it happens during initial stage. V0 increases almost linearly with increase in substrate concentration. Then at higher substrate concentration, V0 increase by smaller and smaller amount in response to increase in substrate concentration. Here. And finally a point is reached beyond which the increase in V0 is very small. This area. This plateau-like V0 region is close to Vmax. That is maximum velocity. This region is close to Vmax, maximum velocity. When Vmax is observed, when the enzyme present in reaction, all enzymes are in the form of enzyme substrate complex. So that time V0 is equal to Vmax. Under this condition, enzyme is saturated with substrate. So further increase in substrate have no effect on rate of this reaction. So here V0 is equal to Vmax. And this is Michaelis-Menten equation. V0 is equal to V mass X divided by Km plus S. So when substrate concentration is equal to Km, what happens? This one, substrate concentration is equal to Km, V0 is equal to half Vmax. This region you can see, half Vmax. That is Km. Km is Michaelis-Menten constant. Here Km is the substrate concentration at which initial reaction rate means the velocity is equal to half Vmax. Okay. So when substrate is equal to Km, V0 is equal to half Vmax. When higher substrate, what happens? Substrate concentration is higher than Km, what happens? So we studied under this condition, enzyme is fully saturated with substrate. So further increase in substrate concentration have no effect on the rate of this reaction. Here V0 is equal to Vmax. When substrate is higher than Km, V0 is equal to Vmax. And what happens when substrate concentration is very low? Here, this one, very low. V0 is linearly increases with substrate concentration. When substrate concentration is very low, V0 is equal to V mass X divided by Km. Or Vmax is equal to Kcat into Et. When Vmax occurs, enzyme substrate complex. That means the enzyme present in a reaction, which form? Enzyme substrate form. Enzyme substrate complex. That time ES equal to ET. That we can study. Okay. ES is equal to ET. We know that V0 is equal to K2ES, which is the rate limiting step K2. So on that stage V0 is equal to K2 into ES. And when this ES equal to ET, that is Vmax. Vmax is equal to K2 into ET. And we can also represent this K2 as Kcat. Sometimes if a reaction contains so many steps, that is K1, K2, K3 and K4, then we can take that K2 as a rate limiting step. So we can represent that K2 as a Kcat. Okay, so here if substrate concentration is very less, V0 is equal to V mass X divided by Km, or V0 is equal to Kcat divided by Km into ETS when substrate concentration is lower than Km. Next class we can study more about enzyme kinetics, Michaelis-Menten equation. Okay, so don't worry, just study these things and wait for next class. We can study more about it. If you like this video, please subscribe and share. Thank you.